So the general process for this model was we got together with a team of scientists who were all working on the site, hydrologists, geologists, engineers, surface water scientists, and determined the different remedial alternatives that we were going to evaluate. So a permeable reactive barrier, a slurry wall, removing upper and lower lake from the site. And then we took all that information and I used that to build a separate model or change the boundary conditions within the calibrated model to then simulate that and see what the results were. As far as calibration, so we calibrated it to groundwater elevations and groundwater flux. That was the flow model. And then we had a contaminant transport model or Phaeton transport model where we calibrated that to measured concentrations of selenium and arsenic. And so we had the groundwater flow model and the Phaeton transport model, and they're coupled together, and had them both calibrated. And then we were able to use that calibrated model to go in and change boundary conditions to simulate our different remedial alternative scenarios.
Yes.
And so we take all that information, extract it from the model, build graphs, build visualizations, and then we work closely with the other scientists and engineers to evaluate which is the most effective remedial alternative based on the model output, costs of how much it's going to take to implement the alternative, and the actual physical constraints of implementing the alternative. So whether you're going to be able to dig a 100-foot hole or not.